in the code now, right? So you people all have got the code now login.
No, sir.
Huh?
What is that, sir?
Code now is a platform where you can log in and you can download the material of ours. Are you being given that?
No, sir.
No, sir.
Shrikant? Okay, good morning all. We'll start the class. So, last class, what did we do? We have done with,
Memory allocation.
remember, we have done with the creation. Okay, so creation is over, right? Now let us discuss about the insertion. Okay, let us discuss about insertion. Hmm? So insertion of a node, insertion of a node. Let us discuss now. So insertion of the node happens in there is two ways. One is when the list is empty, then it has to be inserted as a first node. Then it has to be inserted as a first node. Otherwise, you will insert in between node. You will insert in between node. Okay. Now let us take the case. Now I'll. Okay, I have not shared the screen, right? Yeah. Can you see the screen now?
Yes, sir.
Okay. Right. So let us take today's date, 12th April 2021. Uh, I'm assuming that there is only one, assume in the first case, what is the case one? Is that only start is there and there are no nodes in the list. So if there are no nodes in the list, what would be the value of start? It would be null. It would be null. Okay. And as such, last is also there. There is last also, which we are always having, right? Last is garbage address. It is going to be right. Now whenever a node comes, a node has to be inserted, right? You have called the function, second function you have called, that is what is that function which you have called? For example, you have called the not create function but insert function. So when you call the insert function, there may be chances that your what is that called? Your insert function, when you call, there are two cases where you are going to have. The case one is that the list is empty. List is empty, so you have to insert the node as the first node itself. And the second case is the list is not empty. Then you have to ask from where you want to insert, whether you want to insert at a given position. For example, I have 8 nodes. I want to insert at sixth position. Okay, so what will happen? The sixth node will become the seventh node will become eighth node, and eighth node will become the ninth node. Okay, so like this. So the case one is case one. The case one is this, where the list is empty. List is empty. When the list is empty, that is null. Start is equal to null, then we say that the list is empty. Then the list is empty. Okay, so that has to be inserted as the first node. That has to be inserted as the first node. Okay, so how to insert at the first node? We already seen how to insert it at the first node. Tell me how to insert it as the first node when we have already seen in the create this one. How to insert
Start
in the,
equals.
we are going to say start is equal to new node, and last
Last
is equal to
equals to new
no
node.
no. That's all. That is there is the end of the matter. Okay, right? So Anil, close the door. Okay, sorry. So the list is empty. Then we are going to simply make it as this is a new node which got created. For example, this is a new node. So simply we are going to do start is equal to new node, and also last is equal to new node. That's all. This is what is the insert as a, that is if it is empty. So we'll check if start is equal to null. If we check it, yes, it is true. Then if it is not the case, if it is not the case, right, then so when do we say that there are two cases where now that is, first is that whatever may be the position given, the position what is not important for us, but it is the list is empty. The list is empty means then it has to be inserted at that particular first node. Now there is another case that, for example, I'll take this is start, this is one node, another node, another node. Okay, and this is last, right? And this is start. So for example, this is 3182 2132, right? 8622. So what is the value which is this going to store? The last is going to store 8622, and what is start going to store? 3182. Okay, for example, this is 20, and this is 30, and this is 40. What is the address of the first node going to have? 2132. What is the address part of the second node is going to have? 8622.
8622.
And what is this going to be?
Null.
Is the diagram clear? A single linked list we have drawn. Okay. Now let us take. I am not. When the list is empty, this was the case. When the list was empty, this was the case which you have done. Now the case two is not. It is not empty. It is not empty. Right now it is not empty, but it has got some nodes. In the nodes also, if I give that is the case two, I'll take this is a case two. In this case two also, I'll take that the node to be inserted is first node. That is, I am saying that position of the node, position is equal to 1. Position is equal to 1. That is the first node, it has to be inserted. If it has to be inserted as a first node, right, then what will happen? Now let us take this is a start. Okay, right? And this is the, let us take this is the first node which is there, and already the other nodes are there. This is another node, this is another node. Okay, right? And this is the first node. Okay, now what is happening? This is the first node which is there. So this was a 3182. The other nodes are not important for us. The last node is obviously pointing towards this. Okay, we are not interested. Okay, we are not interested. We are now inserting it as first node. So this is the start. This is 3182. Okay. Now I got a new node. We got a new node, right? Which is at, for example, 2188, and this is new node. This new node. For example, this value was how much? Let us take that. This is 20, right? This is 30. Okay, and this is 40. Huh? So I'm not taking these particular things. The next, this one automatically is understood. Now, this is null. What is this value? Now tell me. This is null. Okay, right. And what is, for example, this value is 10. I want to insert this now. This node has to be inserted as a first node. This node has to be inserted as the first node. What will happen now? Can you tell me what will come now? This node has to be inserted as first node.
Start equals to new
Start
node.
should be equal to new
No,
node.
no. Yes, sir.
Start should be equal to new node. Now, apart from that, tell me what is this particular value going to be now?
3182, sir.
3182.
3182.
So where is 3182 value stored? Tell me.
Start.
It is
First
stored in
node.
start. Now you are saying that start is equal to new node. That means 3182 is overwritten or not?
Overwritten. Yes, sir.
So please understand that you should not overwrite this first, but copy this
Temporary.
particular value to this particular location, and thereafter give the value of new node to this. So how to copy this particular value to this particular place? How do you access this particular location, this address pointer of this new
New
node?
node arrow point
Arrow
PTR.
pointer, arrow
Yes, sir.
ptr is
Equals to
equal to
start.
start, is
Yes,
equal
sir.
to start,
Start.
right? So that the start value is assigned, and thereafter start is equal to new node. So first step is, what is the first step? New node arrow ptr is equal to start. So this step with what will happen? This null is going to be overwritten with with 3182. Is this clear? This step, right? So what has happened now? Actually, a link is established from here to here. A link is established from here to here. Got it or not? Right? So the link is established. Link is established. Got it? Right? Now we have to change the first node address. What is the first node address? It is ఈ పెన్లో refill ఉందా? Huh? Right? Now what is that? This link has to be broken. This link has to be broken. And where should the link come now? This is the link which has to be come to this particular place. Yes or no? So how to
Yes,
do
sir.
that? How to
Start
do that?
equals start equals
Start is equal to
new node.
new node. Start is equal to new node. So I'll write second step is start is equal to new node. Is this clear now? The steps. So case one is what? When the start, when the link list is was empty, right? Then the start is equal to null. Then how it would going to be? Start is equal to new node and last is equal to new node. But when the second case, in the second case, when the list is not empty, in the list is not empty also, first one is what? I have to insert the node as a first node, for example. If it has to be inserted as a first node, then what is the logic you are going to do? New node arrow ptr is equal to start, and start is equal to new node. You're going to do it. Got it or not? Right? So everybody please make a note of this on the screen, what is there in your notes, right? Afterwards we are going to take the note, this one. Next I'm going to give that position is not equal to 1. If position is not equal to 1, then how does it change? Let us see. If it is equal to 2, if it is equal to 3, or if it is equal to 5, like that. Okay, please make a note of it. Everyone please make a note of it.
Sir,
Hmm.
sir, if we need to insert the node between 1 and 2, then what will be
That's
the
what.
first?
Next case. Okay.
Okay,
Don't be in
okay,
a
sir.
hurry. First is
Okay,
case
sir.
one is over. Okay. That when the list is empty, then the case, then the list is not empty in that particular this. First case is what? You're inserting as a first node. Okay. Now the next one is in between node. We are going to
Okay,
insert it
sir.
as in between node. Okay.
Okay, sir. Okay, sir.
Just a minute, I'm taking actually changing the refill of the pen. So any doubts you have in this, please ask. Any doubts? One thing is very, very clear. If you understand this linked list concept, right, then next all 4 units are over for you. It is only the just only theory part. That's all. Everything you can write the program no, afterwards. That is what is importance of this linked list concept. Okay, I'm now changing the page. Okay, then we are going for the next case. Okay, now let us take case 3 is inserting the node as in between node. In between node. Okay, right. Now, when we are talking as in between node, I'll just show you an example. Um, this is your start, for example, right? And this is your first node, and this is your second node. This is your third node, for example. Okay, this is the last. Okay, this is the last. Okay, right? And now this particular this one is 2826. This is 3812. This is 1800. So this is 1800. For example, this is how much? 3812. And what is this value? 2826. And this is null. This is 10, 20, 30 are the values, right? So for example, I want to insert a node between, for example, this is the first node and this is the second node. This is the third node. I want to insert at third position. I'll say, for example, insert node at position is equal to 3. Position is equal to 3. That means I have to insert here. Okay. That means this second, this becomes the third node and this will become now fourth node. Got it or not? Right. So this is the new node now. For example, this is the third node. This is at 3122 address, for example. Okay, right? This is the third node which I have to insert new node. Call new node. For example, the value of this is 25 and this is null. Okay, this is null, right? Null. Now, when it is null, what are we supposed to do? I have to break the link between this. Now tell me, what is the thing which we have to do? See this arrow, what I am showing now. This is a new node which has come. I have to insert at the third position. So this becomes the fourth position. So the second is storing the address of third. So second has to store the address of third. That is 3122 has to be overwritten with 2826. And this becomes the third node. This is becoming fourth node. So the address of fourth node has to be stored in the third node. So this 2826 has to be overwritten in the null plus, right? So now please tell me, how do we access this particular nodes? How do we access this particular nodes? Forget about the last, because this is last. Actually, don't assume it is last. There are more nodes, 7, 8, 9, 10 nodes are there. Then what is this? This is not last. This is not last. Remember, this is not last. Okay. Okay. So then how to do that? How to do that is very, very important. Okay. So now this is 2826, for example. Okay. Now, how to do this? You don't know as of now. You don't know this number. This is the only node which is identified by new node. This is not identified, and this is not identified. So you have to reach from starting onwards one by one. You have to reach till this particular location. You have to reach to this particular location. You, after reaching this particular location, then only you can play around with this one. So for example, this is the node which is there. For example, you call this as some right, some node like temp. Let us take temp. Here it is temp is going to be there. So how to access this particular location? Temp arrow PTR. We are going to access it as temp arrow PTR. Okay, right? This is going to be temp arrow PTR. And how to access this one? You tell me. You don't know this, right? You don't know this particular value. How to access this now? Okay, that is a problem. So this is going to be once again another location you have to give it. Another location. Why you have to access this? Why we have to access this? You tell me. Because this address or whatever has to be assigned to this. Okay. So now how do we access this particular this one? Now let us take is this required or not? Let us see. Is this node required or not? The value we may not require this particular node as the value. Only this, if I take it, for example, this, where do you want to insert now? Tell me once again. We are inserting it as the third node. We are inserting as a node, third node. This is the third node. So at the second node position, I have to get my temp. I have to get my temp at second node. I have to get my temp at second node. So if this is identified by temp, this is identified. How to access the location of this? You tell me. How to access the pointer? How to access the pointer? Please tell. Yeah, temp arrow. How to access this? If it is the first node, how to access this particular pointer? It is start arrow period. Yes or no? This is identified by temp. Identified by temp. Temp is a pointer. Temp is a pointer. Okay. So temp is going to store the node of the current node address. Right. So where we am going to be. I have to be at second location. I have to be at the second location. So temp is at second location. So second location, whichever is the second node, we are here at the second node. If we are here at the second node, how to access the address field of this particular temporary node, right? Temp node. It is
Temp arrow PTR.
temp arrow PTR. And how to access
Yes, sir.
the new node location, address location, new node arrow PTR. Okay.
PTR.
So now let us please everybody see how this link has to be broken, and I have to establish the link to this, and from here I have to establish the link to this. Did you see the figure? So if this established link has to be established, this 2826 has to be overwritten with 3122. So if I overwrite with 3122 starting itself, what will happen? 2826 is going to be lost. 2826 is going to be lost. So first what I will do is I'll establish the link between this 3122 to 2826. So how do I establish this value? Whatever is there is going to be overwritten with 2826, the next node address I'm going to write. After that 2826 is going to be overwritten with 3122. So the steps which are going to be followed is the steps going to be followed steps what is going to follow is, first we are going to write the new node arrow PTR, assign a temp arrow PTR value. What is that? Temp arrow PTR value, assign it to new node arrow PTR. Now what are we going to do? Temp arrow PTR is equal to, you are going to say what? New node. You see the steps what we have done. New node arrow PTR is equal to temp arrow PTR. Temp arrow PTR value is how much? 2826. That is being assigned to new node arrow PTR. That is null is overwritten with 2826. Now after that, what are we doing? Temp arrow PTR location is there, right? So we are assigning new node value to temp arrow PTR. What is new node value? 3122 is being assigned to temp arrow PTR. Temp arrow PTR. So this is what is the logic. Now the question comes here is, sir, how to get the temp with that particular, how do we know which location, how do we access that? There are no names to the this one nodes, there are no names to the nodes, right? So what are the pointers which are available for us, which is start is available and last is available, that's all. Start is available, last is available, and new node is the node which gets created, that is the only. So how to access that particular location, how to get the temp to the correct position? For example, if there are 10 nodes, if there are 10 nodes and I want the node 8th node position, I want to insert 8th node position, I want to insert. Okay, now tell me, 8th node position means new node has to come to 8th node. So where should my temp node should be? Temp should be, temp should be
Seventh
at
Seventh,
node.
7. Temp
seventh.
should be at 7. New node has come to 8. 8 will become ninth node. Ninth will become 10th node, and 10th will become 11th node. Is this clear or not, everyone? Right? Is this clear or not? Now, similarly, for example, assume that my there are total 8 nodes which are available. I have to insert the new node at 4th position. I have to insert at the new node at the 4th position. New node is coming at the 4th position means 4th will become 5th, 5th will become 6th, 6th will become 7th, 7th will become 8th, 8th will become 9th. And where is my temp going to be?
Third
Temp,
position.
Third
temp,
position.
temp is going to be at the third position. Is this clear or not, everyone? Did you
Yes.
understand where the temp should be when you want to insert a node, new node?
Position minus.
Wherever is the position you are asking, before that position it has to be there. Okay, now the question comes is, sir, how do we move? It is not like temp plus plus we do it. No, it is not possible. If I do, for example, temp is equal to, I'll take it as start first. So what would be the value of temp? Now tell me. If I initially take temp is equal to start, what is the value of temp?
None.
I. What is the value of temp is equal to start? What is the value of start here? Tell me.
Here 1800.
1800. So what is temp plus plus? Tell me now.
1801.
18 not 1 or 18 or whatever is the value of that particular, how many, what is the factor, what is the factor? 4 bytes, so it will add by 4 bytes, 18 not 4. But are you going to require to reach to 18 not 4? It is not that. It is not an array that I am going to do temp plus plus. It is not an array that we are going to do temp plus plus. So how to go to the next location, how to go to the next node? Tell me how to go to the next node. Where is the next node address stored in? What is this accessed as? What is this accessed as? Tell me. Come on, tell me. This is start arrow PTR. Start arrow PTR is storing which address? Second
Node
node
1
address.
address.
Node 2 address. Node 2 address. Node 1 address is stored in start. Start arrow PTR is going to be storing what? Next node address. So for example, if temp is equal to start, I do it. What is temp arrow PTR going to store? What is temp arrow PTR going to store? Come on, tell me. What is temp arrow PTR going to store?
Address of node 1.
Next
Your
node, right?
Tar,
Okay. If your temp is at second location, second node, what is temp arrow PTR? Your temp is at second location. What is temp arrow PTR going to store? It is going to store
third
the
next.
third node. If your temp is at fifth node, fifth position, what is temp arrow PTR going to be?
Sixth
Sixth
position.
node address. Sixth node address. Yes or no? If your temp is at 10th node, what is temp arrow PTR going to be? Address
11.
of the 11th node. Is this clear?
Yes.
So how to reach to the next node? How to reach to the next location? Actually, we do it normally a plus plus, a plus plus, b plus plus, like that we do it. But here we will not do temp plus plus, we cannot do it. So how are we going to do it? If I assign temp value as equal to temp arrow ptr, temp arrow ptr is the next node location which is going to be given to the temp. So the present temp value is going to be overwritten with the next node location, right? So what I will do is initially, right, how to move. Movement is very, very important. After moving only this step is going to come. These steps are going to come only after moving, right? Initially, how to move temp to the correct location, to the correct location. This is what is very very important. So I can do one thing in the starting itself. First what I will do is I'll give a temp is equal to start. What we'll do, temp is equal to start. Getting the point or not? So start value has been given to the temp, right? So temp would be at what now? Tell me. Temp is at what? Temp is nothing at the first. What is temp arrow ptr would be equal to? The second node address, right? So when you want to move to the second node, the temp has to move to the second node. What is that we have to assign? Temp arrow ptr has to be assigned to temp. So what I'll do is I'll just say temp is equal to temp arrow ptr. Temp is equal to temp arrow ptr. So what will happen here? The value will the temp arrow ptr, whatever is the value which is there, is will be assigned to temp. So this movement has to take place from first node to second node to third node to fourth node, like that. For example, you are inserting at the sixth node position. Sixth node you have to insert means pos is equal to 6 I'll give. Pos is equal to 6 I'll give. For example, I'll give pos is equal to 6. My temp would be at what location? Temp would
5.
be at fifth node.
Yes, sir.
Fifth node. So temp is going to move from first node to second node, from second node to third node to fourth node to fifth node, and it has to stop there. That means this movement of temp is equal to temp arrow, assignment of temp is equal to temp arrow ptr. It is like temp plus plus. It is not exactly temp plus plus, but it is like temp plus plus. What are we doing is we are moving the temp position, temp from first node to the fifth node, from first node to the fifth node. So the temp is going to move till the fifth node and stop at fifth node. After stopping at fifth node, then we have to do these operations. So first of all, we have to reach to that particular location. Temp is equal to temp arrow ptr. We have to reach to that particular. So temp is equal to temp arrow ptr. If it is repeated 5 times, then you are going to reach to the fifth node. First, initially temp is at first node. When temp is equal to temp arrow ptr means temp will become second node. Then temp is equal to temp arrow ptr. Then temp will become the will go to the third node. Then temp is equal to temp ptr. It will go to the fourth node. Then it will go to the fifth node. Right. So you have to stop there. So what should be the condition for stopping this particular this one? It has to this one has to be in a loop, and it has to continue till pos is what is the pos value? Pos is equal to, you have given it as 6, right? So you take I is equal to, start it from 1. I is equal to 1. I less than or equal to, that is less than pos, right? You have to start moving this. So I'll take I is equal to 1, right? I'll say while I less than pos, I less than pos, temp is equal to temp arrow ptr. So what is this while loop meant for? While loop, this is meant for moving, and I plus plus I'm going to do, sorry, I plus plus, right? Okay. Oh. So temp is equal to temp arrow ptr. Why we are doing this? First, an I is equal to 1. 1 is less than pos is 6. Is it true? Yes, it is true. So it will go inside, and temp is equal to temp arrow ptr. What is temp value initially? Is being this one. What is temp arrow ptr now? First, initially temp is equal to start we have done. How to access temp arrow ptr is this. So temp is equal to, now temp arrow ptr means 3812 is going to be done. So now temp is at this particular location. After that, sorry, it moves to second. After that, temp arrow ptr means 2826 is going to be assigned. It goes to third. It goes to fourth. It goes to fifth. When I become 6, when I become 6, 6 is less than 6 is false. So this won't get executed. Temp would be at fifth position. Now it is at the correct position because you want the insertion to take place at 6. You have done this. So this is what is the logic which is going to be used for movement of temp. This one. Okay, so this is what is going to be done for your when you want to insert it as an in between node. So now let us write then finally create insert function now. And in fact if you want the last node also, you can have a logic. How did you do the last node? So when it is going to be the last node, tell me, in position is equal to 1, then it is the first node. If position is greater than or equal to the number of nodes, that is number of nodes, where is the number of nodes? Tell me, where is your number of nodes stored in? It is stored in n. Did you remember n number of nodes? Right, greater than, if the pos is greater than or equal to n. For example, number of nodes are 8, and your pos position is given as 8. 8 means what will happen? That eighth node will move to the ninth node. That is, it is treated as in between node only. That means if pos is greater than the n, for example, if I give 9 as a pos and your number of nodes are 8, then what it will become? 8 is that is 9. Pos is greater than 8, so it has to be added as the last node. If pos is given as 10, then also it would be added as the last node only, right? If pos is given as 11 also, it is. So if pos is greater than n, then we are going to add it as a last node. If pos is equal to 1, it would be added as a first node. Otherwise, it would be added as a in-between node. Is this logic clear? So now, when you will add it as a last node, we should take that also. How to add it as a last node? How to add it as a last node? How to add as last node now? Okay, so this is start, and this is the first node. This is the second node. For example, this is the third node, and this is last. And 3 is 3826, 1122, 2832. So this is 2832. Okay, and this is 1122. Okay, and this is 3826, and this is null. Okay, and this is 3826, and this is the address. This is stored. Now I want to insert a node, which is a new node, which is node 40. I want to insert it as a last node, so I want to link it here, and the last would be linked to this. Yes or no? This link would be broken. So how to break this link? First of all, last, this is identified first by last arrow ptr should be equal to new node. I am going to do it last arrow. So this is going to be overwritten with, for example, this is 2122 address. This is going to be 2122 address. And now this address, this is null, and the last should be replaced by 2122. So last is equal to new node. Simply, you see, so this order is very important. Like last arrow ptr is equal to new node, and last is equal to new node. This is what you are going to do. That is done. That is added as a last node. When you are going to add it as a last node, if pos is greater than
N.
number of nodes, that is n what we have taken. If position is greater than number of nodes. Okay. So is all the cases clear? First case is what? What are the different cases? Now let us write. What are the cases? First is if the list is empty. List is empty. That is start is equal to null. Right? That is the first case. Second case, what? Right? If position is equal to 1, it is the first node insertion. First node insertion. And the third is if position is greater than n, then it is last node insertion. Last node insertion. Otherwise, it is in between node insertion. In between node insertion. Is this clear, everyone? Right? So now let us write the program. Should we write the program now? You can we write very simple the function. right? So let us write the function now. Okay, right? Okay. What is the function? Let us write the function. Function is what first? That is void insert. Okay, tell me what is that you require here, which was not global, which is
No node,
there
sir.
now.
A
Huh?
no node pointer.
Yeah, yeah, you require a new node. So node star
Star new.
new node. Okay, that is good. And then what do you require? Temp also you require a
Yes,
temp.
sir.
So I'll say star temp.
Sir, I
Star,
also int I.
right. Then I require int I. I require pos position, and I require data item to be taken na value. Value. Okay, value is also required. Yes or no? Insertion na value is required. So these are the things which are required. Okay. Now insert again. You have to take a do while loop. Would you like to continue or not? Char. I'll take ch. Right. Okay. Now what is that we are going to do first? Do. Right. Do. Tell me. You have to be very careful here. Do first is what? You have to take the. What is the first step? Tell me in this. You have to create the node, right? First of all, take the value printf, enter value. Then we are going to store it. Scanf percentage d. Where are we storing? Ampersand value. Now create the new node. New node is equal to node star malloc size of node. Size of node. Okay. After this, what are we going to do? Now tell me. I have got the new node. So how to assign the value? New node arrow data is equal to value, and new node arrow ptr is equal to null. Yes or no? Till here the steps are same as that one. Now we are checking whether it is now the four cases. One is the first one is then the list is empty. So I have to check for first one. If start is equal to null, then it is the first node. So how to add it as the first node? I have already told you. Start is equal to new node and last is equal to new node. That's all. Simple. Over start first one. Else, else part. Else, what is the first case? Now tell me. Next case is if the position is equal. Now, did we ask the position? First of all, tell me, did we ask the position here?
No, sir.
No, we have not asked the position, right? So we are required to ask the position here itself. Okay. Before this, I'm asking here, right? Printf enter position. Enter position. So scanf percentage d ampersand pass. I have taken the position. Now else if pos is equal to 1. Pos is equal to 1. If pos is equal to 1, I have written what is the logic now? Tell me. We have written there. What is the logic? If pos is equal to 1, tell me what is the
Start equals
already we have I have written there. Yeah, yeah. Please tell me.
new node start new node arrow
First is new
ptr
node
equals
Node
arrow.
arrow ptr
PTR
equals
is equals to temp arrow PTR.
Right, temp. ఎక్కడ వచ్చిందమ్మా నీకు temp?
start, sir.
Pass is equal
Start.
to start, and then start is equal
Start
to
equals to new node.
new node. Don't get confused with the other in between this one. So new node arrow ptr is equal to start, and start is equal to new node. Is this clear? This is as a position is equal to 1. Remember, the list is not empty, position is equal to 1. The list is not empty and the position is equal to 1, right? List is not empty and the position is equal to 1. Is this clear, everyone? If list, okay, new node arrow ptr is equal to start and start is equal to new node. Okay, right. Now let us take if the this one is what last node, if it has to be inserted as a last node, the this is close. else part for this. Else again, if pos is greater than n. N is already declared globally. It is available for us, right? Okay. If that is the case, then what are we going to do? Come on, tell me what it is. What is that? Last node. Last node. Last R oblique PTR. Last oblique
The
PTR.
arrow PTR equals to new node.
New node.
Last equals to new node.
Last is equal to new node. Over. This is also done. Now, what is the last else part? Tell me now. Everybody, please, did you make a note of this? Please make a note for 2 minutes. Afterward, don't tell me that, sir, I have not written. Now the last case. Now the last case is very important. The else part. Okay. So the last part, that is the else part. Else. Else what are we going to do step by step? I have shown you what is that first. Before this one, I have to move your temp. I have to move your temp. So initialize temp is equal to what now?
Start.
Temp is equal to start. Good. And initialize, what is the value of I? I is equal to start from 1. Start from 1, not 0. I is equal to 1, you start. Okay. And then what are we going to do? Tell me now. While, what is that? While I is less
Less
than
than pause.
pause. I is less than pause. What are we going to do? Tell me.
New node arrow PTR.
New node. Yes. What did we write there? A new node nahi. Sorry, what is this? I have to move temp na. So how to move the
Sorry,
temp?
sir.
Temp is equal to,
Temp arrow
Temp arrow
PTR.
PTR.
yeah, simple. Temp is equal to temp arrow PTR and do I
I
plus
plus.
plus. You have moved. You have moved now. Till here you have completed the movement. Now you are going to assign. So how to assign? Now you follow the steps. What are the assignment steps? New node
Node arrow
arrow
PTR
PTR is
equals
equal
to
to,
temp arrow PTR.
is equal to temp arrow PTR is equal to temp arrow PTR, and then temp arrow PTR is equal
Equal
to
to new node.
PTR is equal to new node. That's all. You have closed the else part. Close the else part. Now you have completed all the cases you have taken before closing the while loop. What are we going to do? N plus plus you do it. Now close the while loop. Why, right? So before closing the while loop, I have to take. Would you like to continue? Printf like to continue. Like is one more node I want to insert, right? So y oblique n and f flush stdin and then scanf percentile c ampersand ch. I'm storing it, or c, whatever you would like to take. And now close the while loop. While ch is equal to y or ch is equal to capital Y. Right. This is what is your function which you are is going to be insert. Close the insert function. Is this clear? What did we do? Once again, please go through the program. Please go through the program. You make a note of this, then we will. Please make a note of it. everyone. So tomorrow's class, that is not tomorrow, is a holiday. Uh, Happy Gadi to you all. And day after is also a holiday because of Ambedkar Jayanti. So we are going to meet on Thursday once again when we have the class, right? On Thursday morning, we are going to start with the delete. Okay. So deletion of a node, we are going to do it. So we have done with the creation, we have done with the insertion, then we are going to do the deletion, and then we'll do the this one also, how to move, right? How to print also we'll do it. Okay, right? So then if we complete this linked list of singly linked list, then I can go ahead with the topic of your stack and queues. We can go ahead. So when we talk about the stacks, then we have to implement using the linked list also. So then would be very, very easy for you to implement the stacks afterwards. Okay, right? So that's the reason this is very, very important for us. Okay, 211 is absent. 211 is absent. 212 is also absent. 213, 214 is not there. 215, 216, 217 is also not there. 218 is there. And then 219, 220. Right. If the students of this don't have any doubts, they can leave. Except co-hosts, please stay back. Rest all can leave. Only next all means only triple E. Okay. Next comes 6225 present. 26 is present. 27, 28, 29, 6230 is absent. 31, 32, 33, 34 is also not present. 2, 3, 4, and then 3, 5, 3, 6, 3, 7, 3, 8, 3, 9, 4, 0. Okay. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4, 7, 4, 8. These people can leave except Karthik. Rest all cyber security can leave, right? Okay, right. Then 6625 Sai Varun there. 666626 is not there. 27, 28, 29, 30, 31 is not there. 6631. 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. Okay. So now everyone can leave this. Everyone can leave, including the co-hosts. Anybody has got doubt, they can say and ask. Otherwise, you can leave.
Sir, once can you say that else statement what might be done?
Which else statement?
There's a temp equal start I equal to 1.
Temp is equal to start. This is the last case where you have to insert it as an in-between node. So for inserting as an in-between node, you have to wherever you want it. For example, there are 10 nodes, you have to insert at the 7th position. So your temp has to reach to 6th position. So I can't take temp is equal to 1 and do temp plus plus and reach to the this one. It cannot be identified. So temp has to move from one location to the another location. For example, you are in room number 305, you have to move to room number 308 for another friend. From there, you have to go to 411. From there, you have to reach to 315. Like that, you have to move. So can you go in an order? No. From first location, you have to go and see who is the next address. You have to go to that place. From there, you have to reach to the next address like that. Okay, so I want to go to the sixth room. How do I reach to the sixth room? First I have to start from the first room, then I have to go to the second room, then third room, then fourth room, then fifth room, right? And then sixth room. So I have to now insert the node at seventh position. So I have to be at the sixth position. So I am starting with the start of where is the first room, first node location stored in star. So that's the reason we have assigned temp is equal to start and take an I value as 1. So till how many positions, how many rooms I have to move depending on the position. If I say if the position is 8th position, you have to move to the 7th.
Seventh.
So, right, so your I value should once it becomes 8, you have to stop, right? So that is the reason I is equal to 1 you have taken, and you are doing I plus plus every time you are doing I plus plus, so that once you become 8 then you have to stop. Till then what are you supposed to do? You keep assigning. When you go as a individual, when you have gone to the first room, then you ask what the second room address you are going to store and then go, right? That means your variable value you have changed it to second. Then you go to the second room, then you store the address of third room. When you go to the third room, you go show the address of the fourth room. The same thing I am doing. So how are we accessing what is the next door, next room address, or where it is stored in the present this one, right?
Yes, sir.
So how to access the present this one? It is temp arrow PTR.
PTR.
So temp arrow PTR, you are assigning it to temp. Is this clear? So
I
that you are making the movement. After reaching to the correct position, now you are at the correct position. That is the reason you have assigned a new node arrow PTR. The next node address is stored in temp arrow PTR. That you are assigning to new node arrow PTR. And thereafter temp arrow PTR, you are overwriting with the new node. Okay, so that the link is established.
yes, sir. Understood.
Okay, right.
Thank you, sir.
And,
Sir,
yes,
sir, once can you say the difference between temp and temp arrow PTO?
temp. For example, if I'll move to the this one. For example, you take the program, right? Uh, if I take this is for example temp. You take that temp is 3182. Temp arrow PTR is nothing but what is temp location address is location what is storing, that is 2132. Is this clear? For example, if temp is at this particular location, temp is at this location, that is temp is 2132. What is temp arrow PTR? It is 8622. That is nothing but next node. That is nothing but next node. Okay, so if temp is the current node at the current location, if it is as a second node, temp arrow PTR is nothing but the address of the third node.
Yes.
Are you getting the point or not? Right. So that's how we are doing it.
Sir, address block of this program,
Address,
address part of this program.
address part means
That block, sir.
which block?
Address block, sir.
Address block of which one?
This program, sir, means will write
Block
first we
diagram. What
block
diagram?
diagram.
What this
Yes, sir.
diagram you are saying? Huh?
Yes, sir.
Why you require the diagram? It is now you have to understand this. Actually, for example, start is there, last is there, new node is going to come up, right? Something. Now in between node you are doing means the links will break and it will be established. That's all in between. Okay.
It is just a linked
It is a
list
linked
example.
list only. There are 6 nodes. You are inserting at fourth node. Fourth is becoming fifth. Fifth is becoming sixth. Are you
Okay,
getting the
thank
point?
you, sir. Nice.
Why Nitin, you are there in the class?